Okay, this is going to be part 1 of 2 to show how to use the Debug Governor demo project. The first thing you need to do is go to this Debug Governor demo repo and clone it. And I'm pretty sure this is only going to work on a Linux system. Now I'm going to put all these links in the description of the video, so don't worry about it. Okay. So I've got nothing up my sleeve. There's nothing inside this gov demo folder. Let me just go up a directory to my home folder. I also want to point something out, that I do not have a directory called IP_repo. If I had one, it would be in between here and here, and it's not there. Okay, so we're going to do git clone that thing. Oh, I don't think I copied it. Hello. Okay. Okay. And here I'm just going to do, so you have to add Vivado to your path for this to work, and make sure that you have all your licensing set up. Normally you'd have to do source tools, Xilinx, blah, blah, blah. I just have an alias in my bash RC that does this, but you'll have to do that. And you just type make. So when you do this, it's going to open the Vivado GUI, because for this demo, you are going to add in debug governors to an example project. That's what this tickle script is creating as an example project. Okay, so we're going to let that run. It takes a good couple of minutes. In the meantime, let me just grab this terminal window here, make it a little bit bigger. Oh, whoops, I didn't mean to do that. And move this annoying thing up here. Okay, so there's the repo that we cloned a second ago. Now, I would show you right now, but it's still in the process of being generated. But we need to add some debug governor IP cores to certain AXI streams in this project later. Well, to do that, we need the IP core in the first place. So where do you get that? That's inside my yield Verilog repository. I keep all of my Verilog cores in here, or at least I have for the past couple months. We only need debug_gov, which is the debug governor itself, and RR4, which is a round-robin arbiter. We'll see how that gets used later. So grab this repository and clone it. And likewise, we still have to add Vivado to our path for this to work. And here we're just going to run make IP inside the debug_gov folder. So you'll notice right here, even in the transcript here, that it is making the IP repo folder, and it's putting some stuff in it. This is just my convention. I like to have all of my IPs in one folder that I can just add, and I like it to be in my home folder. That's all I have to say about that. Okay, so we go into RR4. We're going to do the same thing. We're going to do make IP. Wait for it. This doesn't take too long, luckily. Okay, so now let's go back up to my home folder. And now you'll notice that, yes, there is now a folder called IP repo. And if we go in there, we'll see that we have, all the proper fancy packaged IP files that Vivado wants. Okay, so we don't need this terminal window anymore. And basically, we just have to wait for this to finish. It's almost done. I guess I'll take this chance to talk about the Verilog files that are included in the demo. The first one is this patched FIFO wrapper, or it's the first one I'm going to mention anyway. I use an IP core called the AXI Stream FIFO, which basically converts, I wonder if there's a good diagram here. It converts from AXI Lite to and from AXI Stream. But here's the problem. It has a bug. Well, it's not really a bug. It's a questionable design choice. One that causes issues specifically with my project. So inside this Tickle script, which is creating the project, I have some, don't worry about this, I have some code here that creates what I call the patched AXI Stream FIFO. It does some pretty shady business, if I'm being honest. The shadiest of all is it edits the RTL for that IP and creates a new IP from it. But in order to add it to the block diagram, you have to create a wrapper for it in Verilog. It is such a pain, but anyway, I did it all for you, so you don't have to worry about it. The other Verilog files that I have inside this debug governor demo are for the actual example thing that we're going to be debugging, and those make a collapse trajectory counter. I'm just going to quickly explain collapse sequences in case you don't already know. A collapse sequence says that if I start with some number, to get the next number, I multiply by 3 and add 1 if it's odd. So this gives me 16. And I divide by 2 if it's even. So we go to 8, to 4, to 2, to 1, and I stop at 1. And the number of times I have to do this, 1, 2, 3, 4, 5 times that I have to put it through to get to 1, this is the trajectory length. I'm not going to write it because my handwriting is too messy. Now, I did this in Verilog by making 4 IP cores. The first one, I think the Vivado is probably finished now. Okay, good. The first one here is this AXIS count. It simply sends out 1, 2, 3, 4 over AXI Stream. This collapse driver is a finite state machine, which the first thing it does is to read a flit from count and then send it out on num. What happens is that this goes into the collapse module, and this module is exactly the operation of multiplying by 3 and adding 1 if it's odd, or dividing by 2 if it's even. So it reads a number from here, does the correct calculation, outputs it there. This collapse driver is going to keep looping the result from collapse back to its num output and count how many times it has done that. And once the output here is equal to 1, it will then send the count on its Zynq output. I only called this Zynq because that's where it goes, into this AXIS Zynq. And this AXIS Zynq is pretty straightforward. It forces its T-ready to 1 and just ignores all its other inputs, and that's it. Hopefully that makes sense. I'm not going to explain it in any more detail than that. Okay, the other stuff that's inside this diagram are these 4 IPs, and currently they aren't really doing anything. Basically, I mentioned earlier that I have the AXI Stream FIFO. So this is my patched version of it. If you wanted an unpatched version, you would just add it like this. And for your interest, if I give it the exact same parameters that I used, you'll notice that the inputs and outputs are identical. I renamed them for reasons I won't get into, but it's the exact same IP, just with the bug fixed. Okay, moving on. So right now, this AXI Stream FIFO is not reading from any streams, and it's not writing to any streams yet. We have nothing to connect it to. That's because we are going to use it to hook up the processor system to the debug governors. So let's go ahead and do that. We want to add some debug governors, so there are 3 steps. The first thing you do is you mark the streams that you want to debug. I like to use green. You can use any color you want. The next step is you have to run this tickle script that I provide. So here's the gov demo folder we've been working in. Here's the clone deold verilog repo. Here's the debug gov folder. There's this file here called addcore.tickle. Now when you run that file, it adds several commands to your tickle console that you can use. And the one that I'm going to show you today is called add debug core to highlighted. It does exactly what it says on the tin. Oh, I forgot a step. Yeah, okay. Well, actually, it's good that you see this error in the demo because this is something that could easily happen because it's easy to forget. It says IP definition not found for the debug gov. Yes, of course, because I haven't added it to the IP catalog yet. I went to the trouble of making the IPs, but I never added them to this project's IP catalog. So let's do that. As I said, they all get generated inside your home folder in this folder called IP repo. And so it added the debug gov and the RR4, so we're happy. Okay, now, I don't know why this happened, but it deleted one of the wires. Well, that's okay. That's okay. It's fine. Let's just keep going here. So add debug core to highlighted. Okay, great. So let's talk about what that did. Let's take AXI count, for example. Now before, this count was plugged directly into the driver. But now instead it goes through a governor from D in to D out into where it used to go. So this governor has been added as kind of like a pass-through on this AXI stream. And likewise, all of the other AXI streams have been passed through debug governors. The next thing to observe is that all of the debug governors are daisy-chained, like this. So any commands that you send to the first governor, governor 0, are also going to get relayed to all the other governors. And where does governor 0 get its commands from? Okay, well now we can connect it to the AXI Stream 5.0. This is something you have to do yourself, is making this connection. This is going to give the processor system a way to send commands to the governors. Likewise, all of the logs and receipts from all of the governors go into this automatically generated round-robin tree. This is basically the exact same thing that an AXI Stream switch would do, except that this tree can be generated for any size. I've done it before with over 750 inputs, and the AXI Stream switch can't handle that, or at least not in a nice way. So this final output is just the combination of all the outputs of all the governors, and we also want to make this available to the Zynq processor system, so we're going to use the other output that I've prepared here for you on the AXI Stream 5.0. Okay, there's two more things that I need you to do, and these are because I couldn't find out how to do them in Tickle. So you notice that all of these clocks on the governors and to the round-robin tree, they're all connected together, but they're not connected to anything else. That's why we're getting this green run connection automation. You need to connect these to the clock that you want to use, so I'm going to do that now. Likewise, there was another thing that I was just never able to... Oh, never mind. It's working now. This wasn't working before, so I'll just quickly mention that normally when you create a block diagram, you have to do this create HDL wrapper. When you do that, of course, like anything else inside Vivado, it spits out tickle commands here. And I copied and pasted those into the tickle script, which is creating this example project. And until now, it has never created the wrapper for me. But this time it did. I don't know why. I really don't know why. But I will take it. I'm just letting you know that. Okay, great. Well, now we're ready to run validate design and cross our fingers that we have no errors. Okay, great. And these critical warnings, actually they're not even critical, they're just warnings. It's basically just saying, dear user, I guessed what the frequency on this clock is based on what you connected it into. Okay, fine. Okay, great. So now what we can do is save this block diagram and run generate bitstream. Okay, so I'm going to end this first part while the bitstream runs, and once it's finished, I'm going to do the second part of this video, which is going to take the bitstream, load it on an MP sock, start a special server that I have, and then start a special UI that I have so that you can actually run the debug governors. And that's going to be pretty exciting. At least I hope you will find it exciting. Okay.